Hey, morning guys. So this is the second day playing around with this BGA machine, and I'm pleased to say that today I've actually had some success with this. I've so far managed to remove a large QFP and also a BGA, quite a decent size one. Unfortunately, I did shoot some video earlier, but the camera wouldn't focus, so we're going to have a third attempt at this. So anyway, I've noticed a few things about the machine. One thing I want to mention first is there's a laser alignment for aligning the nozzle with a chip. I'm hoping you can see that in the video, but in the middle of that BGA there, the red dot, that's the laser. Now, the laser does not actually point directly downwards towards the chip. It's actually from a little unit you can see on the side of the machine, just here. Now, because it's sort of shining down at an angle onto the machine, what this means is, depending on the thickness of the board and even of the BGA, the laser dot can move somewhere in either right or left. So if the board's a little bit thicker, that dot appears more to the right. So it's a little bit difficult to actually know when you have the top nozzle properly lined up with the BGA. But I've discovered another little trick with this. You've got optional alignment on this machine. Now obviously that's meant for placing BGAs when you're soldering them. But what I have noticed, if we pull the alignment out, on the screen here, you can quite clearly see, and it should focus on its own. Let me put the light a little bit. You can see, in the middle of the circular thing, that is actually the centre of that BGA chip. And this here is the nozzle. And what I can do is actually adjust that. So it's a little bit blurred. Just get the focus now. Ah, there we go. Now it's focused. Okay. So now you can see the BGA chip, and you can see I'm rotating the nozzle. So with this, you can quite clearly see that the nozzle is the right size for the chip, and I can also move the board a little bit. I can move it side to side. I can make sure that nozzle is actually lined up properly on the chip. Okay, so I'm happy with that. You can see I've got a thermocouple attached just down there into the chip. Another thing I've noticed now, underneath the machine, if I just get the camera in, you'll see the bottom nozzle. Now that bottom nozzle is adjustable, and I've discovered that you really need to get that very close to the PCB to make this machine work properly. So I can alter the adjustment on that and get it very, very close to the board. I'm just going to move the camera away so I can actually see properly with the eye where that is. Okay, so I now have the nozzle almost touching the board. So that's that set. Now, into the profiles. Let's just let the camera focus a moment. Okay, so on here, it's quite simple. We have a curve select. It's just asking the password. There isn't a password for the operator. Okay. Now, these are your parameters. And you can see I have an option here to choose the curve. So these are the various ones I have. I think basically the Chinese and the English are just the same. Test 1, test 2, and so on. LED 1, 2, and 3. And then we have LED free 2 and LED free 1. Now, yes, I was using LED free 1. I wasn't having any success. So today we're going to use LED free 2 and confirm that. So we now have the profile set up. Back, we're on the operating screen. And literally all we need to do now is hit run. Aha. Now notice a mistake there. I've got the optical alignment out. Let's just try this. I think, yeah, this is not going to let me do something stupid here. Put the optical alignment back. Run. Yep. Okay, so that's one foolproof feature I didn't actually know about. So this is actually going to come down now. And what will happen is, you can see the suction there in the middle of the nozzle. That's going to detect when it reaches the chip. There. And it's now switched on the heaters. So as before, red is the top heater, green is the bottom, the blue is the infrared heaters, preheaters, and that cyan is the thermocouple. And on the graph we can see the temperature's ramping up. Now notice with this profile what happens is, on each stage it brings up the bottom heater first and then the top heater. Also I've noticed the thermocouple is very closely following the heaters now. On the other lead-free one, it wasn't, it was lagging. Okay, so let's let the machine run. Okay, you see that the bottom heater is coming up onto the next phase of the cycle. And there comes the top heater and the thermocouple right afterwards. I will get myself some proper cameras in the workshop here. I'd like to do some more videos, and handheld on the phone just isn't the way to do this. Okay, bottom heater coming up again. And then the top heater, and then you see the thermocouple together, up together. And again. I think this is probably the final push now. You can see it more clearly this time now. The bottom heater's up, there goes the top heater, and just behind it the thermocouple. One more step. So the thermocouple's getting up to 165. And now we're going to see the same behaviour we saw yesterday. So the bottom meter, there it goes. You can see that's obviously switched the bottom meter off. The air's still flowing from the bottom, so the temperature just goes straight down. And in a few seconds, the machine's going to bleep and pick up the chip. And fingers crossed, this time it will work. Oh yeah, and that you can see that absolutely clean, straight off. Right, now the machine's turned the coolers on, so that temperature is going to come down very rapidly now. And that's it, guys. Basically, this is going to complete its cycle now, cooling down. The vacuum holding that chip is quite clever, actually. I don't have any pliers here. I'm not using my fingers, but basically, when you push that up with a pair of tweezers or pliers, the vacuum switches from vacuum to pressure and actually literally blows the chip off into the tweezers. So that's quite a nice feature. You see, as I've been chatting, temperature's coming down nicely, so I'm going to stop this video now. and then maybe we'll have a look afterwards at the results under the microscope.